Boa tarde a todos. Luciana, pode estar me escutando tranquilo?
Sim, boa tarde.
Luciana?
Estou escutando, sim. Obrigada.
Obrigado.
Sim,
Boa
estou
tarde,
escutando.
Bert, are you listening me?
Yeah.
Ok. Então, boa tarde a todos que estão assistindo. Daremos início agora à avaliação da área de ciência de engenharia. Tá? O primeiro projeto é denominado Autonomous Water Covering and the Autonomous Irrigation System of Agricultural Lands, nível médio, área engenharia da cidade de Izmir, na província do estado da Turquia. Mert, you can start.
Okay. I'm sharing my screen. Can you see? Can you see my screen?
You have 5 minutes to your presentation, and the teachers to ask questions to you have 20 minutes, ok? Eu estava falando que ele tem 5 minutos para apresentar o projeto dele e os avaliadores terão 20 minutos para poder fazer perguntas sobre o projeto e outras coisas que surgirem no momento da apresentação. Mert, you can start. Fine? 5 minutes.
Hello, I'm Martin.
Hello, I am Rosanne. Name of our project Autonomous Water Covering and Autonomous Irrigation System of Agricultural Land. It's
Connection. Yeah, okay, I'm resuming. It's projected that world population reach 7 billion. They will increase to 10 billion by 2050. In addition to increase in population, the need for food is expected to increase by 50% in the 2030 due to problems such as destruction of natural areas, global warming, and urbanization and nutrition. At the same time, the ratio of water resources and arable lands is decreasing all over of the world. Uh, you are now map of water resources in 2040 according to World Resource Institute on the screen. The products obtained at the agriculture areas face many risks from the planting stage. The most important of these risks is adverse weather conditions. Meteorological events such as strong storms and winds, strong rain, and flood disaster, droughts, and hail damage agricultural land and cause the complete destruction crops. Therefore, it harms farmers and the country economy. Farmers often cover their fields with glass, mesh, nylon cover, and nylon white canvas cover to protect fields from hail, rain, and excessive sunlight. Uh, However, note that in application, nylon and linoleum and nylon white cross-stitch cover on the plant remain on the agricultural land continuously 3 months, approximately 3 months. Therefore, it's seen that plants reduce the rate of sunlight they receive. In addition, these covers are continuously exposed to factors such as sunlight and wind. So they wear 2 or 3 years. Therefore, it brings extra material costs to farmer, as well as the cost removing and covering covers a seasonal basis. In addition, environmental pollution occurs as a result of this disposing of the old covers in the garbage or by burning them. In agriculture lands to reduce product and cost loss, to save water and energy, to prevent reproduction agriculture pests caused by moisture, to reduce the use pesticides, to prevent environmental pollution, and it's aimed to contribute to economy of the country. You can see the materials we use on the screen, their price. We spent total of $26.50 for this prototype of this project. You can currently see photos of the materials we use on the screen. Arduino Mega 2560R3 was used in this project. In the software, Arduino's own programming language has been applied. Temperature, humidity, and pressure sensors used in the construction of the project are sensors that measure the change in the ambient air and output in analogous manner. These sensors continuously measure the changing temperature, humidity, and pressure values, and estimate the rain and hail station by looking at the temperature, humidity, and pressure changes per hour. You can see the photo R project on the screen now. The aim of the agriculture and food sector is not only to make money, it's also necessary for feeding the rapidly growing population and provide job opportunities. Therefore, many countries resort to smart agriculture and precision agriculture in order to increase profitability, not to be affected by adverse effects of climate change, to meet increasing demand in the markets, and to increase product quality. The current work should be improved in the order to practice become widespread. Necessary support should be given to the farmers. Resources. We would like to thank our advisor Yasemin Horasan and Manisa Viticulture Research Institute Technical Department Dr. Turjan Teker for their contribution. Thanks for listening.
Thank you, Mert. You have a great presentation. So we call teachers that we can ask to you some questions about your project.
Okay.
I will start with teacher Zawa. It's correct?
Yeah, it's correct. Can you hear me? Can you hear my voice?
Yeah,
Yeah,
perfect.
okay. Before we do Q&A session, I want to thank you for your excellent presentation and your project to trying to solve the problem around your environment. Yeah, I have some question. Maybe I see your project is about rainy. Yeah. So can people use the innovation that you can make it? Can the people around you use easily this innovation?
Yes, all people can use these projects. This is innovation maybe because other people's trying this type of projects, but this is maybe has some different other projects.
So what's your novelty about your project than the other project? What's your novelty? What's your innovation in your project?
Our project is not working with internet connection. This causes in the mountain maybe don't have internet connection and don't take a data and can't make a rain prediction. We're using pressure sensors and humidity sensors for this measuring, and you can use this project in everywhere. And other projects not not covering. They not have a covering system. Our project is automatically covering the farmlands with nylon canvas cover.
Okay. So I see your goals is a multiple goal, yeah. So what do you prioritize about your goals? Maybe you must reduce the water, and what's the your priority? What's in your first ranking, I think? What is the function of
Uh,
your goal?
Maybe reducing hail and rain damage. We are first goal.
Why you choose to reduce it? Why you choose the goals to be the one of your list of goals?
Can you sorry, can you I don't understand. Can you repeat?
Okay. So why you choose the goals to reduce it to be prioritized from your project, I think. Yeah, you have a lot of goals. Yeah, so what's your priorities and why you choose it as a priorities?
We priority goal is hail and rain damage because maybe in Turkey hail and rain damaged too much farmlands and too much farm damage and damaging farmers' economy maybe. And we should this any technique can be used in farmlands, but the techniques is not be very good because the cutting photosynthesis and slower growing the plants are projects reducing hail and rain damage and don't didn't I can't
So we have other teachers to ask too. I think your teacher Zawa can be thankful by the answer of Mert, ok? Eu vou chamar agora a professora Luziana Chaves, tá, para fazer algum questionamento. Mert, now a teacher from Brazil, Luziana Chaves, will ask something to you, fine? Or Rosalind, you can answer too, fine?
Okay, hi, nice to meet you. Congratulations on the project. Tell me about little about the software with the Arduino. Yeah.
Yes, Arduino.
And what led you to use it?
Reason, do you want to? Okay. Can you
She wants to know about how you use it, Arduino system in your project.
Yeah.
We use Arduino because we must make a measuring pressure and humidity and temperature and compiling
Yeah.
these data. This is a meteorological predict. These data giving we a hail and rain prediction, and Arduino's making these data compiling and starting motors and covering farmlands.
Okay. Okay. Thank you. No questions more. Okay.
Okay.
Okay. Listening.
Yes.
Yes. Okay. Thank you. No questions more. More. Only congratulations.
Thank you.
You're
Yeah,
welcome.
congratulations for you.
Thank you. What we must to do?
Andrew?
Só estou esperando aqui agora o outro projeto entrar, tá? Que é o de número 361.
Okay. Understood. Dog?
Tô desligando aqui.
Oi, Andrew, tá me ouvindo? Oi, Andrew, tá ouvindo?
Perfeitamente, perfeitamente.
Ótimo. Eu entrei só para ver como é que tava. Coloquei nas outras redes sociais para o pessoal tá acompanhando ao vivo, tá certo? A transmissão de vocês. Porque tem os outros projetos que estão aguardando entrar aí, mas tu já está no controle, tá certo?
Tranquilo, professor.
Tá, tô saindo. Bom trabalho aí.
Obrigada. O outro projeto é o 321, isso?
É o 361. Project ID 361. Arsalan, are you listening me?
Yes, we are. Yes, we can hear you. Hi.
Okay. Can you put your PowerPoint?
Yes. Please wait a second. So we are a group of two, for your information.
Ele disse para avisar para vocês que ele é o projeto número 361.
Tá, ok. 361.
Aslan, put your PowerPoint, please.
I will share the PowerPoint. Please wait.
Aslan,
Yes.
is
There's a
just
problem.
you? Is just you, or do you have other colleagues?
No, it's the pink one.
Okay, okay.
It says the browser has blocked your screen. You need to reload the page.
Ok, I wait you. Ele tá tendo problemas em colocar o PowerPoint, ele vai recarregar a página, só um momento.
Okay.
Okay. I don't know why it's not sharing PowerPoint.
Your screen not appear here to me. Now it's here.
Okay. Yeah, we're
Okay. Everyone is seen.
Can you see your screen?
Yeah. Okay. You can start now. You have 5 minutes, and the evaluator have 20 minutes. Everyone to ask questions for you. Fine.
Okay, so yeah, as I said, there's two of us. It's me, Arsalan, and Mohan. Hello. Okay, Mohan. Oh, okay. Can I start? Okay, Mohan, start. Okay. So hi, I'm Arsalan Firsui, and I'm Mohan Fanda from Iran. We want to explain for you investigate a falling tower by building a robot. Okay. Identical discs are stuck one on top of another to form a freestanding tower. The bottom disc can be removed by applying sudden horizontal force such that the rest of the tower will drop down onto the surface and the tower remains standing. So we have investigated this phenomenon and we can show you the results. So on the left side of your screen, you can see the experiment being done by hand. Is it visible? Okay. So while on the right side, so we need this robot in order to have more accurate results for experiments. So here we have some basic theory. We have Newton's laws 1, 2, and 3. We have normal force and friction, torque, and rotational speed. Theory. Okay, in this slide, I want to calculate angular acceleration. Okay, with torque. For torque, we had two formula. Torque equals Fd and torque equals I alpha. Okay, for the first, we calculate torque with torque equals Fd. After that, in the second formula, torque equals I alpha, we have a torque, but we didn't have a I or inertia. Because of this, we use this formula for find inertia. I equals I plus md power 2. After that, we had torque and inertia. Then we calculate alpha, and this formula about alpha angular acceleration. Okay, we use this formula in the MATLAB code, and you can see the table of this formula. Okay, I would like to thank Armin Zoyeri and Arsha Varyani because they help us to make this robot. Okay, I want to talk about my experiment. I want to calculate V. Because of this, I needed omega. And omega equals delta theta divided by delta t. And then we know V equals R omega. And we find omega with this formula, and we had R. And you can see to this chart, we can change the velocity with this formula. And for example, 1 false and for example 6 not false, and 4 if it means error by a robot. Okay, please look at this chart with possibility of falling and the velocity. When you, if you see this chart, you can see when the velocity is loose, the possibility of falling is high. Okay, I'll take it from here. So in this chart, we can compare the probability of falling with the number of disks. So with disks with 1, 2, and 3 disks, the probability of falling is close to 0. This increases to 10% with 4 disks, 20% with 5 disks, 60% with 6 disks, and from 7 on, it gets closer to 100%. So here, in the third, fourth, and fifth charts, we can compare the different height differences. For example, in the first chart, we have double the height of each disk. From here, we can see that with 1 and 2 disks, the probability is still close to 0, but it increases as we add disks. The same goes for tripling the height of each disk with the third charts. It's still close to 0 with 1 disk, but increases to 50% with 2 disks, and closer to 100 with 3, 4, and 5. When we quadruple with only 1 disk, it won't fall, but with 3, 4, and 5, it gets closer to 100%. So in this table, we want to compare the results. With as we had h in the previous tables, we want to explain that each h is 1 centimeter, and we can compare that with as we add 2, 3, and 4, 5 disks with each with it could be 1 centimeter, 2, 3, and 4. And as you can see, as the number of disks, as the height of each disk increases, there's a higher probability of falling. So in conclusion, we would like to explain that the slower the velocity, the more the probability of falling, the higher the number of disks, the more the probability of falling, the higher the altitude, the angular acceleration is faster, and the probability of falling is more. Thank you for your attention.
Congratulations for your presentation. Now, teachers can ask. I will call Professor Michael. Michael, você pode fazer a sua pergunta e aí eu vou passar para ele, esperar a pergunta e te responder.
Ok. Eu analisei um pouquinho, eu vou estar falando em português, porque o meu inglês ele é bem falho na parte de falar, consigo entender muito bem. Primeiramente, em qual série você está ou já está na faculdade? Como que está aí? Em que período?
Aslan, he asked to you, what is your, are you from high school, college? What is your level of your formation?
I am in 12th grade, Mohan is 11th grade.
It's high school?
It's high school.
I don't understand. Aslan?
High school.
High school. Okay. Now I'm listening. Michael, eles estão no ensino médio.
Ok. Outra pergunta. Por que vocês usaram o F3 ali da Lego, né? Teria uma outra plataforma mais avançada para ser utilizada do que o EV3, né? Ou era o que estava acessível para vocês no momento?
He asked, why do you use it F3 platform? Yeah, why you use it? Do you have access for other platforms more advanced, or is just what you have?
Can you repeat the formula again? We didn't get the formula.
He wants to know why you use the Fee3 platform, don't other.
No more than 3 or 4 because can you let me adjust the volume?
Andrew,
Oi.
tá falhando
Okay.
bastante o que eles estão
Tá falhando
dizendo.
bastante, eu não tô conseguindo o que eles estão. We don't understand what you're telling to us. And your internet connection is too bad. So I will ask to you put your answer on chat and I translate, fine?
Can I answer? Mohan,
Can
like,
you
more
use
than,
chat?
can I answer, please? What is the problem? Can you repeat what you can't
I
comprehend?
will.
You mean that
Are you
increase the height
listening?
more than 4 centimeters? Yes. Why didn't we increase the height more than 4 centimeters?
No. It's not that question. He wants to know why you use it tree platform.
If you for translation of AS3,
Michael, a plataforma é F3, certo o nome?
EV3.
EV3.
É o mesmo que o MATLAB?
Okay, in this experiment, I just want to calculate. Robot, the robot EV3. That was all we had. Okay. My robot, because my EV3, because that was all we had for the road. We didn't have any other platform. Because we're in a soil, that's all
Ok,
we
I
had.
understand. Então, era o que eles tinham acesso e também era o que mais satisfazia a necessidade deles no momento.
Ah, entendi. E a terceira é, ele poderia usar mais o tempo, né, que foi dado a ele, mas do demais o projeto é fantástico, por estar no ensino médio, né, eu pensei que estava na graduação aí, mas parabéns pelo projeto.
So, he told you, congratulations for your presentation. You have to use it more your time for presentation, 5 minutes, you use it less. So next time you can work it, okay? And it's so proud to evaluate your project. Now I will call other teacher, Luciana Chaves. Você gostaria de fazer alguma contribuição?
A minha pergunta, acho que é similar à outra. Por que eles usaram o MATLAB, que eu vi aqui? Posso falar?
So because it is basically quite accurate as they told us that as we were instructed to, this was quite the application that was quite the most useful to us. And my teacher said for physics, it's better you use MATLAB. We also used another one which was called Tracker, but we don't use that anymore.
I understood. Entendi. Excellent project. Congratulations. I am a civil engineer. I loved how you approached the subject. Now have more questions. Congratulations more on us.
Thank you.
Welcome.
Thank you, professora Luciana. Muito obrigado pela sua participação. Now we call Professor Zawa. You can ask to him.
Okay, thank you for your excellent presentation and congratulations to you. Yeah, so I have some question. So yeah, I think you make a robot. That's right.
Yes.
Yeah. Okay. On your device or on your robot, what processor do you use? Arduino, Raspberry, or something else?
If you're talking about the robot, it was programmed by its own application, which is on laptop, both on PC and it can also be used on mobile. It's based on C# programming.
Okay, so I have one question again. You make a robot to detect or to investigate the falling tower, right? So
Yes.
where is the robot will locate to investigate the tower will be falling? Where you will locate the robot in the tower?
Well, they will bring it right now. Wait a second.
Yeah, sorry, I
No, no,
cannot
no.
hear.
They're bringing the robot. No, this is the robot.
Yeah, okay. So where you will locate the robot in the tower, maybe in the
Over
front,
here.
back, or some
Over
where?
here, and we also need to change where we put it so that we can change the acceleration, the velocity. Over here.
We measurement, we calculate omega, and we have R. You can see this is R, and we calculate omega, and when after that we can calculate velocity. With formula, velocity equals omega R.
Do you want to add anything?
Okay. Yeah, so I think enough.
Okay,
Yeah,
I
thank
want to add something.
And we would like to also add something.
Okay. Yeah, you can.
Okay, can I share the screen again? No? No? Okay. Okay.
Nothing.
Yeah, that's okay.
Yeah, something more, teacher? Professor Zawa? More
Oh no,
something?
okay, thank you. I think enough. Yeah, so congratulations to you again.
Thank you, thank you.
I appreciate you of your uh, presentation here now. So thank you very much. Now,
Thank you. Thank you so much.
I will put you out. Fine.
Thank you.
To other
Thank you.
people.
See you.
See ya.
Bye.
Daniel, are you listening? Daniel? Daniel? Project ID 3.
Hello, yes, can you hear my voice?
Yeah, perfect. Okay. Now we call project ID
Hello,
362 from
can you
Data.
hear me?
Yeah,
Can you hear me?
I'm listening to you. Daniel?
Can you hear me?
Yeah, perfect. I'm listening to you. Okay? Daniel? Daniel? Eu acho que ele pode ter perdido a conexão. Vamos esperar um pouquinho.
Can you
Daniel,
hear
are you
me?
listening?
I'm at
Yeah.
the. Yes. Oh, okay. I thought
No.
my voice is not coming.
You
Okay,
can
should I
put your
start?
PowerPoint presentation. You can put your PowerPoint presentation now.
Qual é o projeto dele? Qual é o número, por favor?
362.
Ok, 362. Obrigada.
Okay, can you see my
You have
screen?
Yeah, perfect. You have 5 minutes, okay? Are you listening?
Is my screen visible?
Yeah.
Yeah.
Daniel?
Okay.
Okay. You can
Yes,
start.
yes, I'm listening. How is all right? Welcome to my presentation for how a Saxon bow is used for timing purposes. A Saxon bow is a bow with a hole in space that sinks when placed in water. The Saxons use this device for timing purposes, and we're going to investigate the parameters that determine the time of sinking. Okay, first we're going to investigate the literature. I found literature that investigated this problem, but it had no theoretical explanation and it only had adjusted one parameter. So I decided to conduct a research on my own. My experiment set of our coins, a polypropylene vessel, and a stopwatch and a ruler. Also soldering iron to make a hole, and also a bigger vessel. This is the experiment.
É fresco.
For the forces on the vessel, there's weight, there's buoyancy force, there's drag, and the change in momentum flow for a water cement in the vessel. For the effective coin wear of coins, I had to calculate the buoyancy force of the coins and also the buoyancy force of the vessel. I also calculated that. Also for the drag, I used this equation here, which I needed the Reynolds number for the coefficient of drag. I used the average parameters in my data for to calculate the Reynolds number. I calculated the coefficient of drag from this graph here for my Reynolds number. And also in the second second law says that the changing momentum flow entering a system exerts a force on the system. So I wrote the equations for my vessel and I got this final equation. And this is the summarization of the Newton's second law for the vessel. And these are my final two equations. And these equations can be solved analytically. So I have two solutions. First, I approximated that the H and X parameters change slowly and the system is in equilibrium state. So I will have no accelerations and my equation will be simplified. And I will have the L and V parameter which can be calculated. And from that, I calculated the submersion time. And I can say approximately it is related to the inverse square root of Cohen's mass and the inverse hole area. And these are my data here. And also a better view for my data. It shows that the time of submersion as a function of inverse square root of Cohen's mass. And also another one that shows the time of submersion as a function of inverse hole area. And for my second experiment solution, I used the Python programming language and the programmer tracker to track the motion. It solved the equations for me. And also you can see uh, the results of my simulation and also the track motion. And I have two solutions. My second solution is the solution that the computer gave me. And this is the comparison of the both solutions, the experimental data for the submersion time as a function of Cohen's mass, and also for results comparison for the submersion time as a function of inverse hole area and the function of Cohen's mass. And my final conclusion is that the experiment and the modeling results differ but have a close trend. Both solutions are close, but the second solution is slightly more comparable. And these are because of the ignored effects and approximated parameters.
Thank you for your presentation. Now, Professor Michael, do you have any questions?
Olá. André, eu vou pedir que você também fale a resposta dele, porque está bem falha a internet, pensei que era a minha aqui também, tá? Mas primeiro eu quero saber se ele é do ensino médio ou é da graduação também.
Are you from high school or college? Daniel? Ele respondeu aqui no chat, ele falou que ele acabou de terminar o ensino médio.
Ah, tá, perfeito. A segunda coisa, é uma observação, né? A apresentação dele poderia ser um pouquinho mais aprofundada. Algumas coisas eu não consegui entender.
I've just finished my high school. The research was done when I was in the beginning of my 12th grade.
Ok, we understand. Não, ele só disse que ele colocou aqui no chat que ele terminou isso no último ano do ensino médio dele, tá?
Perfeito. Então, continuando, eu só acho que a apresentação deveria ser um pouco mais profunda. Eu entendi grande parte do projeto, né? Mas um pouco, ou a minha internet deve ter falhado, ou um delay na rede até mesmo dele, que dificultou um pouco no processo dessa avaliação. Mas, assim, eu queria que ele explicasse também qual é o objetivo principal, por que ele desenvolveu esse projeto. Se era um TCC, se era apenas um projeto de iniciação científica.
Okay, Daniel, you are with delay, so I will do the questions and you can answer it, okay? So, listen. Teacher say that he understand deeply your project. It's everything. It's okay, but he wants to know what is the principal aim of your project. And the second question is this research. It's from what? It's a project from your high school or something else? Do you understand?
Out of my school, but it was a high school project. And if you can you repeat the first question? The principal aim of it was to investigate the motion of a vessel inside of in water. I mean, sinking of an object inside water. That was the principal aim.
Ele quis dizer que I'm translating you now. Ele quis dizer que ele procurou entender como é que funcionam, né, vessels, eu creio que seja vasos ou cabos, né? Como é que começa a ser feito hidrodinâmico que esses materiais apresentam. Esse é o principal objetivo do trabalho.
Perfeito, então, parabéns. Realmente é um projeto bem avançado pelas teorias de soma que ele usou ali, que é bem avançado até mesmo para ser desenvolvido durante o ensino médio. Mas parabéns.
Well,
okay. Now,
thank
Professor
you.
Sala, some questions.
Thank you very much. Thank you.
Okay.
I
Yeah.
appreciate
So,
that.
Daniel. Yeah. Okay. Thank you for your excellent presentation again, and congratulations to you. So, I have two questions to you. The first, what the motivate you to do this research? Is there some urgency or some benefit for global from your project? Can you explain more detail about your impact or your application for this project?
Thank Well, what I can Well, it's a physical analysis of something that sinks. It can be used in various places. I mean, anything that sinks in water, I investigated how it sinks.
Okay, more questions?
Okay, no, enough. Yeah, thank you.
Thank you. I appreciate your presentation, Daniel. Thank you very much. Thank you for teachers too. Fine. So, Luciana Chaves, você ainda tem algum questionamento?
Yeah, congratulations for your project. I working on merchant marine ship, and I am a third officer. How can your project help in the constructions of new ships? Because you address some issues like viscosity, water turbulence, and the others. You target about this or no?
Can you
Peraí,
please repeat your question? I didn't understand it properly.
Okay. Uh, How can your project help in the constructions of new ships? Because you address some issues, subjects like viscosity, turbulence, water turbulence, and the others. You target about this. You think about these issues.
Sorry, can you write your question? I
Daniel,
have some delays and disconnection, so I can't understand it properly. I apologize for the inconvenience,
can
but
look in the
if you
private chat.
can type it, I would really appreciate it. Hmm. How can it help in the construction? Actually, it is modeling. Okay. Okay, for construction, well, my project actually is investigating how a ship sinks. So it investigated the motion of a sinking of a ship.
Okay,
It
understood.
maybe it can help when building a ship. We can determine how long it takes for the ship to sink, how is the motion like when it's sinking, and things like that. I think. And
Okay,
also
okay.
the issues of viscosity and water turbulence were very complex issues, and it needed very highly complex equations. So it was, I mean, really difficult to investigate it.
Okay, understood.
Did
Thank
all of
you.
those, so I had to neglect them.
Okay.
But what it actually does is, I mean, it models the thinking and the motion
Yeah.
and what it, I mean, and what it depends on. I mean, I can show my equations again, and it shows how the parameters are related, how it sinks, and what it happens exactly when it sinks.
Okay. Okay. Thank you. Thank you very much. I understood the excellence project.
Thank you to everyone for your participation here. Thank you for Professor Zawa, Professor Luciana, Professor Michael, and Daniel.
Sorry, did
Now,
you say anything? I didn't hear anything.
I am finished the presentation now, Daniel. Thank you very much for your presentation.
Hello, afternoon.
Hello, good afternoon.
Yeah, I'm listening to you. A moment, please.
Okay. Can we start sharing the PowerPoint?
Yeah, you can do it.
Okay.
Qual é o próximo projeto?
I'm sorry. Okay, can you see
Ok.
our PowerPoint?
A moment, please. Agora nós vamos iniciar o projeto de número 254 do ensino médio técnico de Malang, na Indonésia. Now we will start the project number 254 and you can start now.
Okay, thank you. We will start now. Okay, good afternoon to all adjudicators of Musra de Esencia e Tecnologia de Escola SA 2020. We'd like to present our innovation. 450 billion diaper waste are added to landfill store of the country each year. This makes the baby diaper waste ranked third largest in the landfill. If this still occurs to our next generation, what will happen to the earth? This time, let's young generation take action and save the world. Indonesian residents' habit of wrapping each diaper with a plastic bag slows down the degradation of diaper waste because there's a polyethylene as the outer layer of diaper. The degradation rate of PE in landfill occurs very slowly because the open dumping system is preventing PE to be met with bacteria and soil. Previous studies state that mealworms were able to degrade PE, but unfortunately, mealworms would eat PE over their natural food. And this problem inspired us to make a bioplastic that could degrade the existing diaper waste. So, therefore, we Siti Andrani and my partner Priska Kalitapanis to proudly present our innovation with the title of Integration of Indigenous Mealworm Bacterial Isolate of Polyethylene Degrading in the Making of Bioplastic Diaper Wrappings. And bioplastic is made from cassava flour combined with bacteria obtained from that of mealworm. And our goal in this research is to determine the characteristic and ability of bacteria in degrading the PE. And here are the research procedure that we carried out. Okay, next. The results and the discussion. The first is characterization of the bacteria. From our observation, show the bacteria are still present on CFA and agar medium with PE, which means even without carbonic compound, the bacteria still can survive. And bacteria can grow with and without sunlight, which means the bacteria are not photoaltrophic. And bacteria still can survive without ammonia, which shows that bacteria isn't included in the ammonification group. Okay, next is the type of our medium. SEM tests were carried out on control sample P which in PE was incubated on agar medium, and sample C in which PE was incubated in liquid medium.
And the SEM test result for the mineral agar shows that after 20 days, the topography of PE had been degraded, even more in the sample that has been incubated for 2 months. In addition, if compared to the mineral liquid medium, PE in mineral agar medium shows more visible and larger cavities. In liquid mineral medium sample, it can be seen that the topography of PE after 20 days and 13 months has changed. Cavities are seen, and much larger cavities are present on sample that has been incubated until 2 months. Moreover, the biodegradation after about 3 months shows that there were 2 holes that could be seen with the naked eye, which means the damage caused by the bacteria is pretty large. And at 2000 times magnification, you can see that the bacteria are cocci-shaped bacteria, which stick to the plastic surface and appear to be mountainous and coated with biofilm. And next, for the biodegradation testing, we do the treatments with samples where pieces of PE stacked with bioplastic and cotton moistened with either water or urine. And after 10 days, the SEM result shows cavity on the PE surface. It can be seen that samples A and U suffer damage compared to controls whose surface topography is flat and regular. This was caused by the need for bacteria for nitrogen. And this also proves that after bacteria undergo an endospotic phase when the bioplastic is dry, the bacteria will deactivate when exposed to water and will degrade the PE. And from the electrophoresis results show that the genome we isolated still had a large size with a length of 21,226 base pair to 5,146 base pair. So in the whole genome, we expect it to be at around 16,000 base pair. And the bacterial growth shows an increase in optical density value. Although it is not flat, the increase is constant, up to 75 hours or approximately 3 days. And from the GBC test result shows that it is evident that the wide initial molar distribution of PE led to narrower distributions and shifted to lower molar masses when given urine addition treatment. So it is possible to infer that there may have been a rupture of molecules caused by higher amount of bacteria when urine is added. So from our explanation, endogenous bacteria are proven to be activated after a period of dormancy in bioplastics and are able to degrade polyethylene in the outer part of the baby's diaper. And this was about bioplastic have been at the forefront solution for environmental problems for about 50 years until now. and many bioplastics have been distributed globally, but it's inevitable that commercial plastics cannot be avoided from our everyday life. We are looking from a different view, offering a solution to this global problem, and that is to make a bioplastic which is not only biodegradable, but also able to help the degradation of the plastic around them. And also, this study can be a preliminary discovery for further studies, and we will continue to develop this research further for a greener future. And that's all our presentation. Thank you for attention. Responses and questions are welcome.
Thank you very much for your presentation. Now I will call the teachers. Professor Zawa, can you start, please?
Okay, so the first thank you for your excellent project and congratulations to you all. So I have some question. The first is what is the basis or the principle or the theory in your project? I think this is how develop project or R&D project. So what the best or your theory to develop this project?
Okay, thank you for your question. So our project is focused on discover the best bacteria to degrade PE. And at this moment is for baby's diaper. Why we choose baby's diaper? Because baby's diaper in landfill is so abundant, and we have to find the solution of this problematic.
And so let me add some information. So because the plastics in the landfill, there is so much, so we need to degrade the plastic. And one of our friends' research have used mealworm to as a biofuel. But after we do a research further, it turned out that mealworm can also eat plastics. So we try to use mealworm to degrade the plastic in landfill. But if we were to use directly mealworm to spread it in the landfill, it would be inconvenient because it would need so much mealworms, and not all people are used to this kind of mealworm. So, and that's why we decide to isolate the bacteria that is inside the mealworm digestive system instead. So after we isolate the bacteria is added into the bioplastic, and so the bacteria will stay dormant in the bioplastic until it was come in contact with liquid like urine or aqueous or other liquid, and after the bacteria has been activated, the bacteria will be able to degrade the plastic around it.
Oh, sorry. My question is, what the best theory based on theory? What you create a biodegradable plastics, yeah. So what's the technique? What the best you do the every step of your research?
Okay, can we show the PowerPoint, please? So the mealworm, to grow the mealworm needs some substances. There is carbon, hydrogen, oxygen, and nitrogen. So we design the bioplastic where the mealworm can take the substance to grow from it. So the mealworm will metabolize the substance inside the bioplastic, and and so the bioplastic can be damaged with the metabolism of the mealworm.
And so let me add a few explanation for the bacteria itself. So in order to grow an organism like bacteria must have supplies of the elements like the carbon, hydrogen, oxygen, and nitrogen. And while in the medium, which is the bioplastic, there is a limited elements because there is no nitrogen inside the medium. And because of that, the bacteria will stay dormant until the bacteria is met with the adequate amount of elements that is needed, like the carbon, hydrogen, oxygen, and nitrogen. And because of that, the bacteria will need some supply of nitrogen, which is from the urine, and the urine is obtained from the baby's diaper waste. And after the bacteria obtain enough elements, and they will reactivate and then able to grow again, and then they will need food such as the carbon source and then the hydrogen and oxygen nitrogen around them. And as for the carbon source, they obtain from the polyethylene, which is the plastic on the baby's diaper, and then the hydrogen they can get from the water around them, and also the nitrogen is from the ammonia from the urine inside the baby's diaper waste.
Yeah, okay. So thank you for your detailed answer. I think enough. Thank you.
Thanks, Professor Zawa. Now nós vamos chamar o professor David. Professor, e o senhor vai fazer a pergunta em inglês mesmo? Tranquilo?
Eu vou tentar fazer em inglês.
Qualquer
Aí
coisa...
tu traduz a resposta. Qualquer coisa a gente entender.
Okay.
Hi girls. Congratulations on the project. You like to know about the application in your community. I have already obtained support in the project. It's paying the technology. No, I have already obtained the support to the project. I spent the technology on a country to read the material to mix with polyethylene and belongs the project.
Okay. Sorry.
Girls, I have the question. A question is, would you like to know to applicability your community? You have already obtained support to produce spend this technology in your country. The material to mix with polyethylene and belongs the project.
Maybe you can write on in the comment section, sir. Sorry, I didn't get your question.
He wants to know how, if he wants application in your project on his community, how he can do it.
Okay.
I
Okay,
asked in the previous chat. So.
Okay, sir. Thank you for your question. So, so firstly, for this project, we are making a plastic bag, a bioplastic in the form of a bag, and it is integrated with a bacteria. And for the plastic bag, you can use it as the baby's diapers wrapper. So after the baby's diaper waste is wrapped into the bioplastic, and we here produce the bioplastic which is integrated with the bacteria. As for the materials, we here
use cassava starch because it is very abundant in our country, and I'm sure it's also much in other country because it is a staple food.
Okay, sir, let me add some answer again. So here are the research procedure in our research. First, we use a mealworm. Mealworm is very abundant in our country. Mealworm is actually for a bird uh, feeds. Okay, and then after we get the mealworm, we do isolating the cut of the mealworm. After that, we do a culture and some tests like degradation and the best medium, and then we do a bioplastic too. The raw material of our bioplastic is cassava. Why we use cassava? Because in our country, cassava is easy to find, and we already know the reason why we use cassava, and the next research and the next future we will change the cassava with a sorghum. Why sorghum? Because sorghum has same starch content with cassava, but sorghum is planted in marginal land, and it will make the uh, there's a competitive with food production. After that, we do and integrate the bacteria that we have to isolate and culture with the bioplastic that we made. We injected about 10 cube 8 bacteria in every plastic. Before we add it in the bioplastic, we calculate with a spectrophotometry, so the amount of the bacteria will be the same. After that, we do some tests again. So that's all the how we make this our bioplastic. Can you get it, sir? Maybe.
Great, great, great. No ask, no ask.
Thank you, Professor Davidson. Now we call Professor Luciana.
Okay, congratulations for your project. Fantastic approach. Did you estimate the economic value of this project if it were put into practice?
Okay. Thank you. Thank you for your question. And how we commercialize our bioplastic is we commercialize it same sorry we commercialize our bioplastic as same time as the baby diaper commercializing. So the plastic baby diaper bags will be sold at the same time as a commercial baby diaper. And in Indonesia, there are about 10 commercial baby diaper manufacturers that we will go to one by one and propose to corporate. In addition, in the future, it will also be sold separately. We will target for the household needs for moms and the household needs. And our team also has a licensed startup, which is the name is Nilam Corporation, so that the production process can be carried out so that the research has a large and sustainable impact. Sustainable impact. So can I add some we do all this stage by ourselves. We go to laboratory almost every day for a year for beginning the research until we get the results, and we still have a test that The result can be shown here now because it's still in the process.
Okay, thank you. Now, Professor Maicon, do you have more questions?
Olá, tudo bem? Primeiramente, parabéns, o projeto é incrível, né? Consegui entender a ideia, mas eu queria saber também, porque elas colocaram aqui na ficha de avaliação, chegou para mim aqui na ficha de avaliação, que o projeto foi desenvolvido do dia 25/7 desse ano ao dia 30/9. Como que foi desenvolver esse projeto no meio da pandemia?
And he wants to know your project to... professor, você poderia colocar a data aqui no chat, por favor?
Claro, tô colocando.
And he wants to know your project or development from 2050 from July, né, for 30 September, right?
Yes.
Yeah. So he wants to know how you procedure on the context of pandemic.
Okay. Thank you for the question, sir. Actually, our project is not follow the timeline on this competition, but we and our team has started for a year or before a year, and how we do the research while this pandemic. So in the laboratory, there is a tight procedure. Just several people can do laboratory activity there, and before we get it in the laboratory, we have to test. We have to COVID-19 test, and we got the letter that we can do the activity there.
Ok, understood. Elas disseram que a maior parte da orientação foi feita de maneira remota e aí o laboratório que elas fizeram a pesquisa não tinha aquelas limitações de não ter muitas pessoas, elas tinham uma autorização especial para poder entrar e tudo mais para desenvolver o projeto delas neste contexto de pandemia.
Perfeito. A segunda pergunta seria, você já tem um protótipo? Vocês já conseguiram realizar o primeiro protótipo ou ainda só estão nos estudos?
Did you test it or it just hypothetical?
Sorry.
Did you test it or is hypothetical?
I'm sorry, we can't quite understand.
He wants to know if your methodology was tested.
Okay. Okay, sir. We test it in our research. Okay, let me show you. There are some questions we do in our research. First is characteristic of the bacteria. Why we do a characteristic bacteria testing? Because we want to know the best media, and the best maintained in our bioplastics, so the bacteria can grow maximum, can grow grow well. So the first is characteristic. This is to know the bacteria is included as autotroph or heterotroph bacteria. And the result is the bacteria is an autotroph bacteria. So bacteria can
Só um
still
momento, só um
have
momento,
the
vocês
PE. And the next,
só um momento.
okay. And the next
Are
is,
you listening? Are you listening? Professor asked to me, you can talk more slowly for me translator to he, okay?
oh, okay. Mhm.
Okay, so start again, please.
Okay. Okay, so we do some experiment in this research. The first is characterization of bacteria. The experiment needs to be carried out to determine the most suitable media condition for the bacteria to grow stably. If the media conditions are not suitable, we fear the bacteria will die and the isolation
Ok. A moment, please.
okay.
Então, elas pegaram, né, as bactérias e aí elas fizeram um gradiente e aí elas escolheram qual era que vivia com ou sem a adição do polietileno, se eu não estou enganado. Né? Ok, pode carry on, please.
Okay, and the isolation process had to be repeated.
E aí
Therefore,
elas repetiram o experimento para confirmar. Carry on.
okay, therefore, this experiment is very important to do.
Ok, go on.
And the first step, we prepare two agar medium, of one which was given a PE, polyethylene. Here, we want to find out the relation between the bacteria and the PE, whether the bacteria can live or not with the PE. And the result is that the bacteria can survive with the PE for a long period of time, even though eventually the colony will slowly die. Okay, this shows that bacteria don't use PE as their main carbon source. And the
Ok,
second stage,
a moment, please. Você entendeu, professor? Tá travado o microfone. Você entendeu? Ok. Desculpa, eu não entendi.
O final eu não consegui entender muito bem, mas o início
Que
sim.
elas prepararam o meio com as bactérias e aí colocaram diferentes
Sim.
concentrações.
Tá, então ela já tem o protótipo, ela já tem uma sacola modelo.
Sim.
Perfeito. Parabéns pelo projeto, uma excelente ideia.
Ok. Congratulations for your project. It's a great idea. Okay, girls. Thank you very much for your presentation. We appreciate the presence of the teachers. Okay. Now we start the project. Thank you, girls. Thank you very much.
Oh, sorry. Can I add some before we end it?
Can you repeat, please?
Can I add some and continue? And so we really tested it, not just on hypnotize. We do some tests like a medium test, a biodegradation test, and we also comparison it with commercialized PE and bacterial oxidation test, and we do it cross and electrolysis too to know the characterization of the bacteria. So we didn't just hepatitis, but we really do this with a testing stage.
Okay, thank you very much. And he is satisfied with your questions. It's enough. Fine?
And this one came, so we want to, this is a prototype of our product. So the bioplastic will be like this. Will be like this.
Ah, very good.
And this is the baby's diaper, and you can throw in the side and looking like this, and you can throw away in waste in the garbage and we add some warning to not to throw it in the sea on in the river because it's harmful and when we store it, please don't store in a wet place. Avoid any wet place with the bacteria the bacteria can store it well.
Okay, thank you.
Okay,
Thank
like
you.
this. Okay.
City, City, are you
Okay,
listening?
yeah.
City, are you listening?
Yes, this is how to use baby diaper wipers. To throw to the record LDC, throw in the trash, throw in the dry place, avoid touching with the wet hands, hold the handle when you want to use, and always wash your hand after use. Okay, that's all. And will be like this.
I understood. Yeah.
Okay, okay, thank you.
Thank you.
Okay, thank you. Thank you for the comment will be make our research better in the future.
We
Thank
appreciate your presentation.
you.
Thank you. Thank you very
Thank you
much.
very much.
Now we will put the other project. Arcity,
Hola.
okay. Hey,
Hi.
you. How are you? It's fine.
Fine.
Yes.
Put your PowerPoint presentation.
Okay. Okay.
The ID project is 256. O ID do projeto é 256.
Okay. 256.
Girls, you have 5 minutes to explain your project, and after you're done, teacher have 20 minutes to ask questions about your project. Fine?
Okay.
Now
Okay.
you can start, please.
Okay.
Good luck.
All right. Good afternoon, the Honorable the Judges. I'm Arshadila Sofia Fitduha, and my partner, I'm Adilah Nursal Sabila. We are from SMIT Samawa Cendekia Subawa, Indonesia. In this opportunity, we would like to present our research that is biomaterial analysis of the potential of corn cob briquette, candle nut, and coconut shell as renewable energy. Sumbawa Island is one of the islands in West Nusa Tenggara Province, Indonesia. Corn, candle nut, and copra are the leading commodities on Sumbawa Island. Based on the data from Sumbawa Agency Agriculture 2018, Sumbawa Island produced 2,959,222 tons of maize, 285.17 tons of candle nut, and 2.5 till 3.3 tons per hectare per year of copra. From these, the waste automatic increase corn cobs, candle nut shells, and coconut shells themselves. And look at the fact that most of households on Sumbawa Island still use kerosene as their main fuel, even though the ability of kerosene is very small and no longer subsidized by the government. In our research, we use experiments and library studies as a method. We start our research from July 25, 2020 until September 30, 2020. And we did our research in Samoa Cendekia Senior High School, Sumbawa, Indonesia. In this research, we use candle nut shells, corn cob, coconut shells, and also hot water as materials. And for the tools, we use kerosene drums, pounder, modified printing, propellant pipe, and also floor filter. Making briquette start from collect all of those three raw material, then all of those three material have to pass the charcoal process. Then the charcoal that already been made is then crushed and mashed. And add hot water as an adhesive and dry the briquette. The result. The ratio 8:1 for coconut shells, it means we need 8 kg for coconut shells to match 1 liter of kerosene, and the ratio 6:1 for candle nut shells, it means we need 6 kg of candle nut shells to match 1 liter of kerosene, and the ratio 9:1 for corn cobs, it means we need 9 kg of corn cobs to match 1 liter of kerosene. This is the laboratorium test result of corn cobs briquette, candle nut, and also coconut shells. From the table, We know that the three raw materials have a good calorific value, consistent with the SNE or Indonesia National Standard Charcoal Briquette with number 0162352000, which is over 5,000 calories per gram. And from the table, we also know the best raw material seen from energy content or calorific value is briquette that made from canola nut shells, which had an energy content of 7,101.23 calories per gram. This is the important document that we use in our research.
And from this research, we know that making briquette through this way is obtain briquette with a solid texture and cylindrical shape. Then, briquette can prevent the accumulation of this waste material as waste, as well as a big solution for national energy security.
For the analysis of the potential use of corn cobs raw material as charcoal briquettes, 9 kg of corn cobs are needed to match the calories possessed by kerosene. The raw material for the coconut shell is 6 kg, whereas coconut shells weigh as much as 8 kg to match the calories of 1 liter of kerosene. And another pivotal conclusion of this research is that it is necessary to improve the process of making briquettes so that there will be no time-consuming long processing time of briquettes, and that absolutely the costs incurred are less. In the next research, we plan to develop a briquette making process using mechanization tools to produce better quality briquettes, as well as minimize the time of making briquettes.
We also have project to develop this briquette as a burning medium for essential oil as aromatherapy.
This is the reference that we use in our research. That's all from us. Thank you.
Thank you, girls. It's a very great presentation. Now we call the teacher David Ferreira to do your questions or contributions.
My question in the private chat.
He will ask on private chat.
Sorry.
Wait a moment. Look at the private chat. Close your PowerPoint presentation.
Okay.
And look at the chat. Moment, please.
Yeah. Okay, thank you. Actually, for our own area, not many people use briquettes. That's why we want to introduce our project to general public, and this is the our prototypes. Yes, this is. This one, I think. This one. Okay.
One more question.
Sorry.
Now we call teacher Luciana. You can ask one question or contributions.
Okay, excellent project. Congratulations. How did you want to develop this project? It was out of concern about the environment pollution and the energy security? Yeah.
Okay. Can we share our PowerPoint again?
Yeah.
Especially we made this briquette because briquette can be alternative for reduce the using of kerosene that causes global warming. Why? Because the combustion of kerosene produces elements of CO and CO2. They accumulate in the air and will produce a greenhouse-like effect on sunlight that will enter the earth. So, by using briquettes, we reduce CO and CO2 as a result of the burning of fossil oil fuels and have helped prevent global warming. And also, the briquette can reduce felling trees for charcoal making. Because nowadays people still use charcoal in general as one of fuel. But for making charcoal in general, so we have to use some wood and most of them felling trees. So with this briquette, it can reduce felling trees. I think that's all.
Okay, I understood. Thank you very much, Susa, for you.
Thank you, Professor Teacher Luciana. We can Professor Michael.
Primeiramente, parabéns, um excelente projeto. Realmente chegar numa fase final com um protótipo pronto, né? É sensacional. Parabéns.
Congratulations, girl, for your project. You can go something, you can use it. You understand? You developing a tool. Okay, and the teacher is very impressive with your project. Congratulations.
Thank you.
Professor, você vai perguntar alguma coisa?
Não, sem perguntas, entendi perfeitamente.
No questions. He understand all of your project, and congratulations again. Professor Sala.
Thank you.
Yeah, okay. Thank you for your excellent presentation and congratulations to you, girls. Yeah, so I have some question. So, what is the novelty of your research? I think it's a lot of briquette in innovation. So, what's make it your briquette is have added value compared to others?
Okay. The novelty of our research, compared to existing research and also our previous research, we use hot water as the adhesive and comparing three waste from three main communities on the island of Sumbawa that are corn cobs, coconut shells, and also coconut shells. We also analyze the potential of this three raw material and determine the best raw material as briquette seen from the energy content or calorific value. That's all. Thank you.
So I want to ask one question again. So I want to know about what's the method of your research to make the briquette. Can you explain detail more? What's the step or methodology you ask based on your research? What's your methodology?
The methods of our research that is experiments and also library studies and we start of making briquette with collecting all of those three raw material. Then all of this three material have to pass the charcoal process. Then charcoal that already been made is then crushed and mashed and add the hot water as an adhesive. Then form it using modified printing tool and we dry the briquettes.
Okay. So yeah, I think enough. Thank you.
Thank you.
Thank you very much for your presentation, girls. Professor, we finished the evaluation for today. So So we from MCTA appreciate your participation here, and we're so proud to you be here. Ok? Professores, muito obrigado, viu, pela contribuição de vocês e esperamos firmar nossa parceria aí por muitos e muitos anos, viu? Muito obrigado mesmo pela contribuição de todos.
Thank you.
Thank you.
Thank you very much. Tchau, tchau.
Thank you very much.
Thank you very
Bye-bye.
much.
Bye, bye.
Mhm.